Let's learn the application of differentiation, rates of change. So if you have a differentiation called dy over dx, it represents the rate of change of y with respect to x. Similarly, if we have v as the volume of an object and t as the time, I can write this as dv over dt, which represents the change of volume with respect to time. Okay, so that's what it actually means. Now, the differentiation can be used to tackle many real life problems. So, for example, speed, distance, and time. Okay. So let's see what. Let's first understand what does it mean. So suppose if one person is traveling from point A to point B, this whole distance is called the distance traveled is called displacement. Okay, and it is usually denoted by s. And then the speed with which he is traveling is called velocity, is denoted by v, and the time is denoted by t. Okay, now we know that s is equal to v over t. Sorry, v is equal to s over t. Let's not worry about that. So we have three variables now. S is the displacement, v is the velocity, and t is the time. Okay, and there's one more factor what you have to work on here is the a, which is called the acceleration. Okay, so let's work with all these things. So we have S, we have V, and we have A. Again, reiterating, S is the displacement, V is the velocity, A is the acceleration. These all are with respect to time. So T is the factor with which we are trying to work on these three variables. Now, the rule of differentiation says that if you differentiate the displacement with respect to time, dt, you will get the velocity. If you differentiate the velocity with respect to time, you get the acceleration. Okay, so this is the rule. Now let me just write it once again. V is equal to ds over dt. Okay, and a, acceleration, is equal to dv over dt. If you understand this, you will be able to handle a lot of problems in your leaving cert, because this kind of questions have seen repeating. Okay, now usually what they do is like they give s as a function of a variable. Maybe for example it is 3 plus 2t plus 4t square, or they might give the velocity as half t square plus 3t plus 5, something like this, and then they will ask you to find the other variables. So if you remember this one, you will be able to find out what they are trying to ask. So let me take an exam question here and try to work on the topic which we learned. So pause this video and try to read this question. So here what they have given is they have given a velocity. Okay, and they're saying that it is passing a point A on the motorway. So if you can visualize it, it is passing on the point A on a motorway, and this v over t is the velocity at any point uh, with t, which means that the object has traveled a distance of t minutes, or t minutes, and at that time the velocity is given by vt, and that is this function. Okay, now they're asking us to do the calculation. So let me just try to clear this off and read the question once again. So here what they're asking, work out Fiona's speed when she passes the point A. So as I said, it is passing the point A and it is at t. This is where the v of the velocity function is applicable, so which is v of t. So when she passes the point A, the time will be 0. Okay, so what you have to do, you have to sub in the value t is equal to 0 in here. So that's v of t, or v of 0. I would write it as v of 0 here, which is 2 over 3 0 cube minus 6 0 square, 6 times 0 square plus 13 times 0 plus 109, and 0 will all will get cancelled, and you will get 109 kilometer per hour. Okay, now the second one, work out Fiona's acceleration. So what is acceleration? Acceleration is equal to dv over dt. That's equal to, you have to differentiate this. So differentiating this, you will get 2 over 3 times 3t square. It's a normal differentiation, minus 6 times 2t plus 13. Okay, there's a differentiation, so 3 and 3 will get cancelled, and this will become 2t square minus 12t plus 13, and which is 5 minutes after she passes the point A, which means that t is equal to 5. So at t is equal to 5, A is equal to 2 times 5 square minus 12 times t plus 12 times 5 plus 13, and that is equal to, you can calculate this and you will get 3. So kilometer per hour per minute. Now the next one is, find the time, the value of t at which Fiona reaches its maximum speed during the first 4 minutes after she passes the point A. So whenever you think about maximum speed, it is when dv by dt is equal to 0. So what I can do is, I can write this as 2t square minus 12t plus 13 is equal to 0, and then you solve this using minus b formula. So it is like minus of minus 12 plus or minus square root of minus 12 square minus 4 times 2 times 13 over 2 times 2. Then you can get the values as t is equal to 4.58 or t is equal to 1.42, and the maximum will be at 1.42.